Hello everyone, welcome to today's class. This is Teacher Simon taking you through A-level mathematics. This is mechanics paper 9701 stroke 45 for May June 2025. This is actually the first time we are seeing this variant 5, okay, in 2025. The rest have variant 1, 2, and 3, and now there is this 5 here. Probably the number of regions increased. Okay. All right. Question 1. A box of mass 25 kilograms is pulled 12 meters up a rough plane inclined at an angle of 80 degrees to the horizontal. The box moves up a line of greatest slope against a frictional force of 50 newtons. The force pulling the box is parallel to the line of greatest slope. The box starts from rest and has speed 2.4 meters per second at the end of the 12 meters. Find the work done by the pulling force. It's like work done by the driving force. Okay. Now, in my simple sketch here, I'm going to have this box here. So this box which is being pulled, there is resistance force which is 50 what? Newtons. Okay. Now, there is driving force since they are telling us to find the work done by the pulling force. You see that? Then when it comes here, it will of course have a driving force, but the distance in here is 12 meters. You see that? Then this is 8 degrees. So by connecting these 2 points here, we shall have this vertical height here. And you know that sine of an angle, let's say that 8 degrees is equal to the opposite, which is h over the hypotenuse, which is what? 12. Okay. Now that means that our h is going to be equal to 12, then sine of 8 degrees. I'm going to use the energy method. So when we start here, they're saying the box moves up. Is it starting from rest? Yes, the box starts from rest. So since it starts from rest, then that means that it has zero kinetic energy. So there is no kinetic energy here. We also don't have potential energy because it is on this. This is our point of reference. So it is on that point. Therefore, there is no vertical height. But now when it reaches here, there is speed. So here u is equal to 0. There is speed here, which is 2.4 meters per second. So since there is speed, then that means there is kinetic energy. And there is also potential energy because of this vertical height which is generated. You see that? So using the work energy principle, if you have been following me, you must have come across this, that I say work done by the driving force, then minus work done against the resistance force, work done against resistance force, or work done against resistance, then is equal to the change in mechanical energy. And mechanical energy is the sum of kinetic energy and potential energy. So work done by the driving force is actually the one we are looking for, work done by that pulling force. You see that? Okay, then minus work done against resistance. Remember, work done is equal to force times distance. So this is the resistance, which is 50, then times the distance it travels, which is 12, then is equal to change in mechanical energy. So we have this one here, the final. So we have a half, then times the mass, which is 25, then times V, which is 24 squared, also, and then plus potential energy is mgh. So m is 25, g is 10, and then our h is this one here, which is 12, then sine of 8. So meaning that work done by the pulling force or the driving force, 5 times 12, that is a 60, but then there is another 0 here, so this will be 600. And then what is this one here? And then this one here. So plus, but then this one here is going to be 25 times 10, that is 250, then times 12, 25 times 2.4 squared, then times the 0.5. This one gives us 72. And then how about this one here? 25 times 10, then times 12. This one is giving us 3,000. 3,000, then sine of 8 degrees. Make sure that your calculator is in degrees. So work done by the driving force is therefore going to be 600 plus the 72, then plus 3,000 sine of 8. So we are getting 1089, and the rest of those figures 1089, then 0.5193. Okay, and the rest, was it 03? I think, yes, 03. Then I can write this answer here to 3 significant figures. Okay, so therefore work done by the driving force is going to be, maybe round off that to that, it will be 109, then 0 joules. As simple as that. This is to 3 significant figures. Question 2, a machine. This is about momentum. Yeah, a machine for driving a nail into a block of wood causes a hammerhead to drop vertically onto the top of the nail. The mass of the hammerhead is 1.5 kilograms and the mass of the nail is 0.005 kilograms. You see the diagram. Then the hammerhead hits the nail with speed 32 meters per second and remains in contact with the nail after the impact. You see? So they coalesce, they form one word particle. Part A, calculate the speed with which the combined hammerhead and the nail move immediately after the impact. Give your answer correct to 3 decimal places. Okay, so this is momentum. I'll look at the principle of conservation of momentum. Momentum before collision is always equal to momentum after collision. Okay, now let's continue. So we have the mass of the nail, the hammerhead is 1.5, then the speed is 32. Remember, momentum is product of mass and velocity, then plus the nail here is not moving, so its momentum is what? 0, because we shall have mass times its speed, which is 0, or velocity. Then momentum after collision, if they stick together, we are forming one particle, so the masses are going to add up together, so you have 1.5, then plus the 0.005, then times the speed here. So that means V is going to be equal to 32 times 1, that one will give us 32, then 0.5 times 32, that one will give us 16, so 16 plus the 32, that is 48, then we shall divide by, this is 1.505, okay? So what will be the value of V here? 48 divided by 1.505. I can write 9600 out of 301, but to 3 significant figures, V is going to be equal to 3.9. Okay, we have, in fact, not 3, it is 31.89, and the rest of those figures. But by the way, they said we give our answer to 3 decimal places. When you look at this one here, those figures are recurring. Okay, so we are going to have 31.894. 31.894. Three decimal places. If you give to three significant figures, you will have 31.9. And that will be wrong because they said the accuracy we are supposed to have is 3. The degree of accuracy is 3 decimal places, not 3 significant what? Figures. Then they are saying there is a constant force resisting the motion of magnitude 25,000. Okay, so yeah, what are we going to have? So we are going to have these two together. Let me just draw it like this. One particle, it is going down. Okay, there is a resistance to motion which is 25000. You see that? Now there is no force that is actually taking this one down. Okay, so we are going to have um, 0. Remember, I can use this F, which is equal to MA, then 0 minus 25000, then which is equal to, the total mass is 1.505, then times A, meaning acceleration, which is actually deceleration. Here we are having a negative value of acceleration. That is what we call deceleration. Meters per second. Now we need to find the distance traveled. So I'm going to use v squared is equal to u squared plus 2as. Now after impact, okay, after impact, this is the velocity the combined particle moves with. You see that? So that is now the initial speed for the next movement. So this particle is going to go, if they are saying calculate the distance the nail is driven into the wood, it is going to move down and then it will stop. Okay, it will stop. So meaning the final speed is going to be equal to 0. The initial is going to be this 9600. Let me use the exact. Okay, over 301, then squared, then plus 2. The acceleration is this negative 25000 out of 1.505. You see that? Then times the distance we are looking for. I can take this one this side to be a positive. So 2 times 25, that will be a 50. So we shall have 50, then 1000 out of 1.505 of S. Then it will be equal to 9600 out of 301 and then squared. So meaning S will be equal to the whole of this 9600 out of 301 squared, then divide by 50,000 out of 1.505. So what will be our answer here? We have 9600 out of 301. Then we can square this one here. Now we divide by again another fraction here, which is 50,000 out of 1.505. So that is the answer there. But then to three significant figures, that one will be 0.0306. 0.0306 meters. Three significant figures, as simple as that. Question 3 is coming from kinematics. A train travels 4.8 kilometers between two stations A and B. The train starts from rest at A and accelerates at a constant rate until it reaches a speed of 30 meters per second. Okay. It then travels at this constant speed for 40 seconds before decelerating at a constant rate, coming to rest at B. The total time for the journey is 180 seconds. Now let me first draw the velocity time graph for this one, how it looks like. Okay, it will help us interpret this well. So we have this, it goes up to there, it starts from rest, not so? Yes, and accelerates at a constant rate until it reaches 30 meters per second. So that means this one here is 30. This is velocity, which is in meters per second. And then this is time, which is in seconds. Okay, then it continues. They say that it continues with this constant speed for t seconds. So we shall go up to here for t seconds. So let's say if this one here, the time for the first movement here is t1, okay? If I take it to be t1, then we add on this capital T, the time taken here. That means this one here is going to be t1 then plus t. Are we there? And then it decelerates until it comes to rest. And then here we are seeing 180. So that is that. Now, what do we have here? Now, when you look at this one, it is a trapezium. Okay? We know that total area under the graph, always gives us the total distance traveled. Now, when we look at this total area, this is area of a trapezium, which is a half h into a plus what? B. H is the vertical height. Okay, this one here, the height, and then a, those are the two parallel sides. So a can be this one, and then b can be this one. All right, now let us have, this is our t, by the way, like that. Here, a half times our h is 30, and then a is this t. Okay, a is that t, and then b is the whole of this, which is 180, and then we equate to the total distance traveled was given as 4.8 kilometers. So 4.8 kilometers is the same as, in meters, multiplied by 1,000. So this is 15 into t plus 180, which is equal to 4800. Now t plus 180, actually t is going to be equal to, we shall get this 4800, we first divide all through by 15, then we take the 180 this side by subtracting it. So meaning t is going to be equal to 4800 out of 15, then minus 180, 140. As simple as that. Now, hence find the distance moved by the train while traveling at a constant speed. Now, at constant speed, okay, acceleration is equal to 0. Now here we cannot use the three equations of motion because acceleration is not there. And you know that in those three equations of motion, v is equal to u plus at, s is equal to ut plus a half at squared. We also have what else? V squared is equal to u squared plus 2as. A is there. Okay, so if you are using those equations of motion, then you are going to have s is equal to ut plus a half at squared. You see that? And a is 0, so this one goes. That means you have the speed, then times the time. So in other words, we are using this one here, the relationship between speed, distance, and time. So speed times time actually give us the distance. So our distance is therefore going to be equal to the speed multiplied by the time. And the speed is 30. Then the time taken, we have seen t is what? 140. You see this one here? Okay. So 3 times 14, that is 42. Then we shall add on these 2 zeros. Okay. Meters, 4,200 meters. Question 4 is coming from resolving of forces, coplanar forces of magnitudes 17 newtons, 51, 34 act at a point O in directions shown in the diagram where tan alpha is equal to 15 over 8. Okay, but find the magnitude and the direction of the resultant of the 3 forces. Now we are given tan and tan of alpha. We shall need sine of alpha and then the cosine of alpha. Okay, so I'll draw a triangle here to get the values, the exact values of sine alpha and cosine of alpha. So if this one is alpha, then we shall have tan is opposite, then over adjacent. So meaning this one here is going to be 15 squared, then plus 8 squared. What do we get? Square root of 15 squared plus 8 squared. That is 17. So I'll write here 17. So meaning sine of alpha is going to be equal to opposite over hypotenuse. And then cosine of alpha is equal to adjacent out of hypotenuse. Okay, now we are supposed to resolve these forces horizontally and then vertically. Even this one horizontally, then vertically. Even this one the same. All right. So what I usually do is to draw a cross that represents all. Okay. So I'll draw something here and then here. Now, up here, I've already said that when you are closing the angle, that is a cosine, because you are bringing the hypotenuse onto the adjacent, and using SOHCAHTOA, cosine is the one that connects the adjacent and the hypotenuse. So putting this 51 down here, we shall have 51, then cosine of alpha. You see that? And then, so closing is cosine, opening will be sine. So putting it here, it will be a sine. So here I will have 51, then sine of alpha. Then coming to this one, we are closing in this angle, so that one will be a cosine. So 34 cosine of alpha, and then closing it here will be 34, then sine of alpha. Then how about this one here? Now there is an angle, this one is forming the horizontal, so we need to find out that angle here. Okay, so let me make this one dotted. Now from here, there is going to be that angle there. Okay, that angle, if this one is 90, remember these are angles on a straight line. So if this one is 90 degrees, then alpha and this other angle must give us 90. So in other words, this one will be beta. So what will be beta here? Beta is going to be equal to 180 degrees minus 90 degrees, then added to alpha. So when we open up, 180 minus 90 degrees, then minus alpha. So that one is 180 degrees, and no, it's going to be 90. 180 minus 90, that is 90, then minus alpha. So that is what we are having there. Now, that means here I'm going to have you close it. Let's close it here. We shall have 17. Okay, 17 cosine of beta, and then opening it up will be a sine. and then 17 sine of beta. You see that? Now, from here, they said magnitude and direction of the resultant forces. Now, you should know from trigonometry that sine of let me say sine of beta is the same as sine of 90, okay, then minus what? Alpha, because we have gotten it here. Now sine of 90 minus alpha is the same as cosine of alpha. For example, if alpha is 30, okay, 90 minus 30, you'll get what? 60. So sine of 60 is root 3 over 2, which is the same as cosine of what? 30. Okay, just like you can have sine of 30 degrees, which is equal to cosine of 60 degrees. These two angles are complementary. You see, 60 and then the 30. So that is that. And this also implies that cosine, okay, we also have cosine of beta, cosine of 90 minus alpha, then is equal to sine of alpha. You see that? All right. So what are we going to have here? So let's check this out. The resultant in x. The resultant in x. So this one minus this one, we shall have 34, then cosine of alpha plus 51 cosine of alpha, then minus 17 cos beta, okay, cos beta, which is, let me write 90 degrees minus alpha. Okay, so let us first simplify this one. Cosine of alpha is common, so 51 plus 34, isn't that 85? That is 85, then cosine of alpha, right? Then minus, this will be 17 sine what? Alpha. So 85 cosine of alpha is 8 out of 17. Remember what we did here? Then minus, this is 17 times sine of alpha is 15 over 17. You see that? So this one goes here 5 times. So 5 times 8, isn't that 40? That is 40. Now 40 minus the 15, because this one will go, that one will give us a 5. Okay, that 25. So the resistance, the resultant of forces in the x direction is 25. So I did this one minus this. So that means these two forces here are bigger than this because we got a positive value. That means the resultant in x is going this other side. Okay, keep that in mind. Then let's go to the resultant in y. So the resultant in y is going to be equal to, suppose I say this one here, 51 sine alpha, then minus these two that are opposing, we have 17, then sine of beta, which beta is 90 minus what? Alpha. Okay, then there is also 34 sine of alpha. So this is 51 sine of alpha minus 17. Sine of 90 minus alpha, we have seen it is cosine of what? Alpha. So I'll write here cosine of alpha, then minus 34 sine of alpha. Now 51 minus 34, because sine alpha is common, that will be what? 17? Yes, this one will give us 17 sine of alpha minus 17 cosine of alpha. So this will be 17 times sine of alpha. We got it up here as 15 over 17. So 15 over 17. Then there is a 17 here times cosine of alpha, which is 8 over 17. So this one can go. You see? Then 15 minus 8, we are getting a 7. So meaning that the resultant in y is equal to 7 newtons. Okay. Now, I did this one here, and then I subtracted these, and I've gotten a positive value. So that means the resultant in y is acting upwards. So meaning I will have, I'll have this one here. So here we have ry, and then here we have rx. So meaning the resultant of the forces is going to be here. Let's say you are pulling something. It is here. You have a rope that is passing behind, and then here like that. So when you are pulling this way and this way, the particle is going to move here like that. So that is why we put the resultant of the forces in between here. You see that? Okay. Now, we are going to have the resultant force in here. So if I shift this one here and I put it onto this, I'll form a right angled what? Triangle. So meaning our ry is going to be that. So RF is therefore going to be these three form a right angled triangle. So the magnitude of R of F is going to be, using Pythagoras theorem, Rx squared, then plus Ry, then what? Squared. So we shall have the square root of 25 squared, then plus 7 squared. And Rf therefore becomes square root 25 squared, then plus 7 squared. And that is root of 674. Root of 674, which we can write to 3 significant figures. 26.0, okay? 26.0 newtons. That is to 3 significant figures. So that is that. Then the angle is going to be this one. So we have tan theta, which is equal to ry over rx, and ry is 7, rx is 25. So meaning theta is going to be equal to the arctan of 7 out of 25, which gives us arctan of 7 out of 25. This one will give us 15.6. 15.6 degrees. Now, this angle we have gotten here is above the positive x-axis, okay? If we had a force here, okay, here, then we would have said direction is those degrees 15.8.6 15.6 degrees above that given force. But now we are going to say 15.6 degrees above the x-axis. All right. So I'll state my direction here this way. Direction 15.6 degrees above the positive x-axis. So that is that. Then here they are saying the force of magnitude 51 newtons is replaced by a force of magnitude p newtons. You see? Then they are saying acting in the same direction. The resultant of the three forces now acts in the positive x direction. So first of all, we are going to have again our diagram here. Okay. That diagram, up here we had 51. Let me refer to this one here. 51 sine alpha. So that means this one will be P sine of alpha. Then 34. Then down there we have 34 cos alpha. Then P cos alpha. 34 cos alpha. And then P cos alpha. Then down we have 15 sine beta. No, 17 sine. Is that all right? 17 sine of beta. Sine of beta. And then we also have 34 sine alpha. Then this way we have 17 cos beta. Okay, now they said that the resultant of the three forces now acts in the positive x direction. So it is here. That means the resultant in y is 0. Because if the resultant in y is 0, we are only going to have the forces acting here. You see that? So we shall say Ry is equal to 0. Okay? So P, in other words, P sine theta is equal to these ones here. So we shall have P sine of alpha then is equal to 17 sine of beta, then plus the 34 sine of alpha. This is P sine of alpha, which is equal to 17 sine of beta. Remember, beta is 90 degrees minus alpha, which is the same as the cosine of alpha, not so. So P sine alpha then will be equal to 17 cosine of alpha, then plus 34 sine of alpha. Now our P here is going to be equal to 17. What is cosine of alpha? Is 8 out of 17. 8 out of 17, then plus, this is 34, times sine of alpha is 15 over 17. 15 over 17, then we shall divide by sine of alpha, which we have seen it is 15 over 17. Now this one will go here 2 times, then 2 times the 15, you'll get 30, and so, and then this one will go, so 30 plus the 8, that will be 38. So here we have 38, okay? Then we are dividing it by 15 over 17, which is the same as saying 38, then times the reciprocal of the denominator, 17 over 15. I'm going to write my answer to 3 significant figures. What will this one be? 38 times 17 out of 15. The answer is 43, then 0.06 recurring. You see that? But to 3 significant figures, that will be 43.1. 43.1, okay? Newtons, that is to 3 significant figures, as simple as that. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.